Thank you for introduction. Let me my talk. That is what is the iterator and how does it build an ecosystem in Go. You can access this slide via this URL, and if you don't understand my pronunciation and my English, you can read my talk script on the speaker note. Okay. I'm Takuya Ueda, call me TennTenn. I'm a software engineer. I work for Manage Work in Tokyo, Japan, but I live in Hokkaido. I work from home. So I also Google developer expert in Go category. A board member of Gopher Japan, which is an NPO. This NPO supports local Go community in Japan and organize Go conference in Japan. This is content of my presentation. My talk is divided into 3 sections. The first section is what's iterator. Second section is what's new with the iterator in Go 1.3 plus. The last section is how does the iterator build an ecosystem in Go. Does anyone know iterators in Go 1.23? The iterator is a new feature in Go 1.23. The iterator can access any data structure sequentially with a for range statement. The changes, there are 2 big changes of for and for range statement in Go 1.22 and Go 1.23. The first one is about loop variable scope. If a loop variable might be captured by a closure or escape to the heap, the for statement creates new variables at each iteration. That means you will not face terrible bugs with writing TT or TT in your unit test. This feature is very great. This feature was already released in Go 1.22. The second one is range over integer and function. For range statement accepts integer and functions. The range over integer was already released in Go 1.22. The range over func is well known as iterator, will be released in Go 1.23. If you try to the iterator, it is available by build with setting rangefunc to the variable GOEXPERIMENT in Go 1.22. The new for range statement accepts 4 different range expressions for integers and functions. The 3 types of functions differ in the number of values they handle in each iteration. These functions receive a function, which receives 0, 1, or 2 values and returns a Boolean value. How do we use this new feature? Let me explain the iterator and how it works. What is an iterator in Go? The iterator provides sequential access to arbitrary data structure via a function. In this talk, I call it seek function. For example, if we want to handle a tree in a for range, you should create a seek function that accesses each node and call it from the for range statement, like this. This is an example of iterator. The seek function is called function. The seek function is called once per range statement. For example, this code print in seek1. Yeah. But does not print in loop. Because the yield function is not called in the seek1. On the other hand, the yield function passes values to the for range iterations. Seek to call the yield function twice. So the for range iteration done twice. This is an example of a depth-first search for a tree. In the first iteration, seek calls the yield function with a node A. Then the variable v becomes the node A in the iteration of for range. In the second iteration, v becomes the node B, and so on. If an iteration will be break, the yield function returns false. So we can know the time of stopping the iteration of the seek function by the return value of the yield function. This code breaks in the first iteration, so the seek prints false after in loop. If we want to dynamically change the access data structure, you can put a function on the for range that returns a seek function. The old function takes an in slice and returns a seek function as a value. That pass each element of slice to the for range statement. If we are thinking why this code does not take the slice directly in the for range, it is correct. But iterator works well with combination. The new iterator package in Go 1.23 provides two defined types of sequence seek functions, iterator seek and iterator seek2. These type function there are two examples of seek2 and seek. All functions take a slice of any type with type parameter and returns seek2 int v. That means all converts a slice to an iterator. And second example, values function takes the value of seek2 kv and returns seek v. It converts seek2 to seek. It drops index or key. Okay, live coding time. I go 1.22.3. I will show an example of range over integer. It is very convenient. And we can use this feature in Go 1.22. Next. This code doesn't work in Go 1.22, but build with GOEXPERIMENT call rangefunc. It works. This is the most simplest example of iterator. For range calls seek function only once. So we should create accessing data structure as a seek function. I will show the next example of all function, which convert from slice to iterator. Iterator package is a new package in Go 1.23, so Go import command cannot import it.
Okay.
It works. Return to this presentation. Okay. According to Lars Cox, who is a core member of Go team in Google, there are two styles of iterator functions: push and pull. The Go iterator is push style. The push style passes the iterated value to the function as parameters. On the other hand, the pull style return the iterated value from the function. So the iterator package also provides a pull and pull-to function, which convert a push style iterator to a pull style which convert a push style iterator to a pull style function. These functions return two functions. The first function is a push style iterator. The first function is a push style iterator function. Next, the function returns a value and Boolean value, which indicating whether to continue or not. The second return value of pull and pull-to is stop function, which stops the iteration. The stop function is useful for iterators that use some resource such as files and network connections. There is an example of pull. Pair is an example of using pull function. Pair takes an iterator and makes pair from the iterator. Pull and pull-to are convenient to get merge pull values from an iterator. The return value of pair is also an iterator of created pair. How long remain?
10 minutes.
10 minutes?
We have to take 10 minutes.
10 minutes. Maybe I have no time to recording time, so skip this. Okay. The next section is what's new with the iterator in Go 1.3 class. There are milestones of iterator. This milestone includes my prediction. So the milestone may be changed and the prediction may be wrong. In Go 1.23, the rangefunc iterator package will be released. The proposal of adding iterator-related functions to slides and maps was accepted and merged to the master branch in Go. The proposal of new package iterator. This is an experimental package, new package, and it has not accepted yet. After Go 1.24, more iterator-related functions will be added to the standard library. For example, bytes, strings, GOEXP, and errors package. There are 8 iterator-related functions which added to slice package. For example, all converts a slice to an iterator and corrects the values from an iterator and return as a slice. So we can convert from slice to iterator and convert to from iterator to slice. Maps package also provides 5 iterator-related functions in Go 1.23. Finally, keys and values comes to maps package. maps.Keys is convenient to use with slice sorted this function because in Go maps.Keys it does not it's not sorted with foreign statement. So we should sort keys with sort package or slice package in Go 1.22. Iterator will provide many useful iterator-related functions. We can use filter and map function with a third-party library such as LO. Provided function has not decided yet, but I think we can use this function experimentally in Go 1.23. There is a proposal which adding all and all as to errors package. Currently, the wrapped or joined errors form a tree and cannot access sequentially. Errors join is provided, but errors split is not provided. The proposed errors all can access an error tree by depth first search as an iterator. Errors as can accept a joined error, but it returns only a fast compatible errors in depth first search. The proposed errors all as can get all compatible errors via the returned iterator. It works well with conc.poo package, which is a useful package for concurrency. It is third-party library. This is an example code of error O. Error 1 and error 2 are created by errors new. Error 3 is wrapped error of error 1. And then error 4 is a joined error of error 2 and error 3. It forms a tree such as this. Errors all can access each error via the iterator. And this is an example of all as. Error 1 and error 2 are values of my error. Error 3 is a joined error of error 1 and error 2. Errors all as can access each converted errors via the iterator. The last section is how the iterator builds an ecosystem in Go. There is a history of iterator. Slice, map, and similar functions are proposed with generics in Go 1.18. But these functions had not accepted with generics. So in the first discussion of iterator, the iterator is proposed an interface, but it has a problem for compatibility. In the second discussion of iterator, the iterator is proposed as a function. It solves the problem of the first discussion. Finally, last Cox proposed the iterator as a range overfunc, and it has been accepted. Go provides ecosystem through abstraction. There are two examples of them, I/O and file system. I/O reader and I/O writer provide abstraction for I/O. Network connection, file, and many data types can be handled transparently as I/O reader and I/O writer. And FS provides abstraction for file system. Any data, for example, zip file, can be treated as a file system. I think iterator makes new ecosystem in Go. Iterators seek to provide abstraction for access to data structure. Any data structure can be represented as sequential data. Functions, for example, X iterator map and filter can receive an iterator, changes it and return another iterator. That means these functions can apply any data structure. I think there are two use cases of iterator. The first one is sequential access to data structure, such as arrays, slice, maps, graph, and tree. The second one is iteration of function calling and error handling. I think both I/O scanner and SQL logs will be provide iterator-related function or method. Okay. Iterator is very useful data structure, so you can try to iterator in Go 1.22 with GOEXPERIMENT variable. Okay. That's all. Thank you for listening.
Thank you for your speech. 不还在请问大家有没有什么问题呢 ？Do you have any question you would like to ask? Okay, please. Do you have a microphone? Anyone to take?
Hi, my name is Jason. I have some question about the iterator. You say in the title, the end of the title, you can use this, the iterator in data structure. Does this iterator can use in the channel?
Sorry, trade-off?
Yeah, channel, yeah.
The Go team members said maybe most use case of iterator can be optimized, compile time optimization. So most case is very cheap or cost for iterator, but you can access network or file in seek function. So it's very high cost, heavy cost. So maybe this iterator is very slow. But most case is maybe very cheap or cost. Okay? If you understand my lesson.
Okay. Another question. I have another question. While we use in the let's say the Go routine, does they have some side play with like, or we use the iterator with the Go routine? Or that means multiple Go routine can access the iterator with the answer.
You mean thread safe?
Yeah, stress that.
Iterator is not thread safe, so you should use sync mutex or wait group in seek function. Because thread safe is very high cost for performance, so we can select options without thread safe and thread safe. So you can sync package. Okay, that's all.
Okay, thank you.
Thank you.
Thank you. And we have one question on Slido. And the question is that does a feature of a 122 arrow phone look ever iterator range function? The first question.
Yeah, first question. Yes. Also, effect.
Okay, and next question is, are there any performance topic we need to notice when using iterator?
Yes, but you can check performance by benchmark test. So do not guess. Robot said. Yes, but yes, but iterator is very newest feature. So iterator might have performance problem, but so we can use iterator and check performance in our production code. So and feedback to Go team about performance problem.
Okay, thank you, TennTenn. Do you have any question right now from our audience? 我们现在还有2分钟可以提问哦，不知道现在的观众有没有什么问题想提问呢？我们再等个10秒钟。Oh, and one question. Okay, from Sean. What's the scenario should we apply iterator of function feature?
If you use LO, which is a third-party library, LO provides map or filter function. So you can maybe replace this library to X iterator package in 1.3.
Okay, and final question, was it 1 minute? Will it be more likely to cause initial loop problems?
Yes. Yes. Iterator is just function. So you you can create an infinity loop easily. So, yes.
And I think it's all question right now. And thank you for TennTenn. 非常谢谢大家。One more question. Okay, you're lucky. Can we have a microphone?
I think.
Hold on, we have a microphone later.
Oh, thank you. I'm Damien. I think simplicity is a very important feature of Golang. How do you think iterator affect the simplicity of Golang?
It is a good question. I think iterator brings some complexity to Go, but iterator also reduce some complexity of Go other cases. For example, we don't have iterator in Go now, so we should write function to get keys from maps. So after release iterator, we just use maps.Keys and slice sorted. It is very simple, I think.
Thank you, TennTenn. Let's Peterson, our time is up. If you have any question, I think TennTenn is still in this for right. So ask question for TennTenn, we'll be waiting for you. 不好意思，因为时间已经到了，所以我们不能再问更多的问题了。但是TennTenn呢，今天还是会再次承楼当中，所以呢，有问题可以跟他提。